Hi there, your old pal Doc Capacitor here with another episode about capacitors. Oh, excuse me. Hello, Dr. Capacitor. Yeah. Okay, it's me. No, I didn't leave him at home. No. Yeah, okay, I'll check my car. Just relax. All right. Listen, I'm in the middle of something here. I gotta go. Okay, dear. Yeah, anything you say. I'll check again. See you later, boss. Failure. It's unpleasant, but it's something we have to talk about. Besides, great failures breed stronger pathways to success, or something like that. You want to learn from failure? I got just the thing. But first, the intro. That's right. Today we're talking about failure modes. Here's the thing. Every capacitor is going to have its moment in the sun and then wear out. But sometimes capacitors fail earlier than we expect. I wish it weren't so. Failures happen to customers all the time. Any number of things can cause a capacitor to go south. Ready to hear about the top 10? Say yes. Number 1, contamination. Yuck. What contaminates a capacitor, my friends? Halogens. Halogens mainly come from cleaning solutions and conformal coatings. Why are halogens such a problem? Because a little goes a long way. You see, halogens react with the capacitor's oxide layer, severely damaging it. It actually destroys it. And as Pops always said, too much halogen can wreck the oxide layer. Telltale effects of contamination include open circuit, vent activation, loss of capacitance, and increased leakage current. Talk to your doctor. Me. If you think you have a contaminated capacitor, or better yet, call before using any halogenated material. There is a solution. Clean smart. Use deionized water, alcohol-based cleaning solvents, or no clean fluxes. Number 2. Rough handling. Capacitors are just like us. They need love. And when they don't get it, their aluminum cans get damaged, dented, holes in them, you name it. Now, I'm not pointing any fingers, but when it comes to rough handling, you got to ask yourself, what happened in the warehouse during the shipping process? And don't forget your buddies at the shipping company. Bottom line, you could end up with useless parts leaking electrolyte, and that's not good. Make sure your personnel know how to properly handle containers. Retrain them if you have to. Number 3, excessive charge discharge. You can get pulled over in some states for that. Excessive charge and discharge can put stress on the leads and its connections. Your best bet here is to get a capacitor designed for repeated charge and discharge. As always, if you're in a jam, call Nichicon. My buddies and I can give you the skinny on the best capacitor for your application. Number 4, stress! Now you may be thinking, why can't these caps just mellow out a little? I'm talking mechanical stress, kids. Improper lead forming puts unnecessary stress on the capacitor's end seal, causing contaminants to seep in. You know, like those nasty halogens. In this case, the lead form was too close to the capacitor body. Something could have pulled or twisted the lead wires. I don't know. I wasn't there. The solution is simple. Purchase parts that have been already formed properly. Number 5, excessive ripple current. When the ripple current goes above the ripple current rating of the capacitor overheats. It's anarchy. Another no-brainer. Use capacitors with a ripple current rating that meets or exceeds the applied ripple current. Stay awake. We're halfway there. Number 6, excessive heat. A capacitor sleeve can shrink when things get a little heated. Storing the capacitors in direct sunlight? Not a good idea. Come on, they're capacitors, not hydrangeas. So now what? Try a lower drying temperature, or a different drying time, or a combination of the two. Lucky number 7, overvoltage. This one's a lot like excessive ripple current. Basically, the applied voltage exceeds the voltage rating of the capacitor. Then the capacitor heats up, the electrolyte turns the vapor, pressurizes the capacitor, and the poor kid has an accident. Electrolyte everywhere. The applied voltage has to stay below that capacitor's voltage rating. Do you notice the pattern here? Number 8, reverse voltage. What's that? That sounds like someone putting a capacitor on a circuit board backwards. And it ain't pretty. The oxide layer forms onto the cathode, and before you know it, the capacitor gets a little too warm, bulges, and blows its top. The answer: bipolar capacitors, which are far more forgiving. That way, if you're mounting capacitors onto a circuit board, and say your mind wanders to the stock market or a leg of lamb, it'll go on right every time. Number 9, reactions to cleaning solvents. Not everybody likes baths, least of all electrolytic capacitors. Some solvents can contaminate the capacitor or react negatively with the capacitor sleeve. The solvent can get trapped under the sleeve, cracking and or deforming it. There are a few ways we can clear this up. For example, ordering capacitors with a different sleeve material. Changes in the cleaning system can also help. Changing the water pressure, changing the water temperature, changing the spray angles, changing to a different solvent, or best yet, changing to a no clean flux. And finally, number 10, old capacitors. Capacitors are built to work. They don't like sitting around the house doing nothing for long periods of time. As much as you might want to stock up for the apocalypse, it's best to get our boys in the field and working as soon as possible. You don't want them to turn into that in-law that moves in and sits on the couch all day watching TV. Yeah, you know who I'm talking about. Listen, kids, it can be a real drag to talk about mistakes, but again, failures allow us to grow. They also teach us how to better inform our customers. It's a win-win. Thanks for joining me today, and remember the name Dr. Capacitor.